Hello everyone, welcome to week 11 of getting started with competitive programming problem solving session. Today we are solving dynamic programming problems. So the first problem is that you are given n jobs with start time s and finish time f. So si and fi for ith job, and each job has a value v. So two jobs are compatible if they don't overlap, and the goal is to find the maximum weight subset of mutually compatible jobs. For so the problem statement is very small and clear, that you are given n jobs. Every job has a start time, finish time. Two jobs cannot be done simultaneously if they so you cannot take two jobs that overlap with each other, and every job has a value associated with it, and your goal is to find the subset of the jobs which are mutually compatible and maximize the weight of the jobs. So for this example, first we are given three jobs. First job starts at 1, ends at 2, and weight is 10. Second is starting at 2, ending at 4, weight is 20. And the third is starting at 3, ending at 4, and the weight is 5. So here, clearly if we choose the job 2, then if we choose job 2, we will get a profit of 20. But if we choose job 2, then we cannot choose job 1. Okay, I think here I have so let us assume here, I think this is assuming that the end and start time should also not be same, then they are compatible. But otherwise I can modify the problem here, saying that the start and the end time, if they're same, then also they're compatible. But this example particularly is just saying that if a job is ending at 2 and another one is starting at 2, then also they're not compatible. So in that case, job 2 is not compatible with job 1. So if we pick 2, we cannot pick 1, and if we pick 2, then we also cannot pick job number 3, because that is starting at 3 and it will collide with job 2. So the answer is 20 for this case. Now I'm sure most of you would have seen the version of this problem which was unweighted, where you were given n jobs with start time and finish time, and you were asked to return the maximum number of jobs that can be done. So can some of you tell me that solution for that problem, unweighted job scheduling?
We can sort according to end time and then pick the
Yeah.
we can sort according to end time of the meetings and pick up the best ones.
Yeah, pick up the best ones would mean?
uh, like the another meeting which would be starting as soon as the current meeting
And
ends.
yeah, yeah. So we'll sort them in ascending order of their finish time or increasing order of the finish time, and we will pick, let's say, the first job which is finishing at the earliest, and then we will discard all the jobs which are colliding with it or overlapping with it, and then pick the next one which is not overlapping or is compatible, and we'll do the same, repeat this. And that was the greedy approach that worked there. And the intuition behind that is that we have this resource here which is time, and we want to finish the job as soon as possible so that we have more time left with us to, and in that time we can do more jobs. I think that is the intuition behind that. Now here we have a weighted version, that's the only difference. And now instead of the number of jobs, we have to maximize the profit or the weight by choosing the set of jobs. So will the same greedy approach or some other form of greedy approach work here?
Uh, no, I don't think so. Greedy won't work here.
Yeah. Even if we sort in the descending order of their weight, like even if we greedily, so I'm just asking, so if we greedily pick the job with the maximum weight first and then pick the next maximum if it is compatible, uh, will that work? That seems to work for this example that is there on the screen. Can you uh, give an example where it won't work, or will it work?
Yeah, like in this example only, if we replace 10 and 5 by 15 and 15, then it will contradict.
Right, right. Yeah, yeah, nice. Yeah, it won't work. So then, what? So then, think of something else.
It would be basically the examples where like the let's say the jobs.
Let's say the jobs. Hello. Hi, Kushagra. Sorry, but I can't hear you. Can others hear him?
No, I think he has some network issues.
Okay. Kushagra, can you try again? Okay, just give it a thought for some time. So, have you seen 01 knapsack problem, or yeah?
I was also like kind of like a knapsack problem because every job here we can see that we have a choice that if we take it or not. And if we are taking that job and it is not in our job stack already, then we'll add it to our job set,
Hmm. Yeah.
and then we'll add its value. Otherwise, we won't add its value, and we'll return the maximum value that we are taking. Something like that.
Yeah. 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 Something like that. Can you try to derive the exact recurrence relation, or not the recurrence, like recursion, uh, recursive relation for this? So when you are saying that you will choose this job, then what will be the rest of the remaining set of jobs that you can consider? And if you discard this, then what will be the remaining set of the jobs that you can consider? I think that.
In both the cases, I think the remaining set of jobs that we consider would be n minus one for sure, because this the nth job is being cancelled or approved, but the
Hmm.
remaining jobs are still left to be checked. So that would be n minus one. And for the value, if we don't use it, the value stays same. And if we use it, the value changes, but we have to add it somewhere in a set so that we can later check on if this value is used in. I mean, if we can use this as well or not. Like they should not overlap it.
Mm, what
We
should
have
not
to check
overlap?
their overlap as well.
Yeah, yeah, we have to check the overlap as well. Yeah. So if, uh, yeah, what you said was, I'm not sure if you said it fully correctly or not. If you want, you can just think for some time and then again repeat what you said. Kunal, have you seen 01 Knapsack?
No.
Okay, no problem. We discussed it the last week actually in Friday's meeting. This problem is similar to that, so maybe after today's class you can go try that. Okay. Kushagra, would you like to repeat your answer?
Yes. So what I said was, like
Yeah,
for
I'll,
uh,
I'll write.
what I'm thinking is for each job, we'll have to. I mean, we'll choose if we'll take it or not. So
Yeah.
that would be exactly similar to knapsack problem.
Yeah. So we have a binary
Just
choice for every.
yeah.
I'm writing. We have a binary choice for every job. That is the similarity between these two problems. Yeah.
But the thing here that is difficult and more important to be considered is we can't choose any job that is overlapping any previous job we have chosen, right?
Yeah. So we need to choose only compatible jobs. So I would like to first uh, repeat the first point. So what the first point is saying, that for every job that you are given n jobs. For every job there are two options. Either you will take that job in your answer. So you will output an answer set, that this is the answer, these are the jobs that I can do. So either a job will be part of that answer or it will not be a part of that answer. So you have only two options. So that is what is meant by binary choice for every job. So let us say all jobs were compatible with each other. Then how many ways, like how many subsets of jobs would have been possible, compatible jobs would have been possible. So 2 to power n possibilities would have been there, because I'm just saying that all are compatible. It's And then total number of subsets of compatible jobs would be 2 to power n, because every subset is a set of compatible jobs. So then next point is that we need to choose only compatible jobs. That is the condition that is given in the question. Now what were you saying next?
So I was saying that like the first point we have is similar to the knapsack problem.
Yeah,
The second one isn't. So we'll have to devise a method to check it.
right,
So
right.
either we can do in recursion, like we can store the values of like the chosen jobs or something, and that was what I was thinking right now. I'm pretty confused
Chosen
about this.
jobs. Right. So
We-
mm, so let us consider that you have 1 2 dot dot j minus 1 j. These are your jobs, 1 2 3 up to j. Now when you are at job j, and now you have two options, either to include it or not include it. If you don't include it, then you can return the answer for 1 to j minus 1, right? Because
yes.
you have not picked j. So now you do not need to discard those jobs which are not compatible with it. But if you pick jth job, this job j, then you need to discard all of those jobs which are not compatible with it. So what will you do if you have to pick j?
Most probably we'll take a check the remaining jobs and I mean discard them kind of or blacklist them
Yeah,
if they are overlapping J.
yeah, yeah. So then what will be the answer? What will be the answer here?
Second value to be passed should surely be J minus 1 for the answer. But for the first, I am confused. Like, we have two attributes, two parameters. So the second parameter would be J minus 1. But for first, I can't see. it would be value plus j minus 1 maybe. Sorry, value comma j minus 1.
Oh, this
But
you
again,
this actually
yeah.
I had meant to say the range of all the elements, so I should remove this. It is only j minus 1. If you are, we can write it like this. Here it is implicit that the elements are starting from 1. There I had explicitly written that the jobs from 1 to j minus 1. But I meant only that answer for jobs 1 to j minus 1. So here
Maybe we'll add the profit of j to the previous answer.
we will add the
Profit of j to the answer of j minus 1.
here you mean vj here.
Vj minus 1.
Okay. There is a little bit of
Okay.
problem here.
One thing that I saw just right now is what we can do is like if you sorted all the jobs in an order
Yeah.
based on basically maybe their starting time, I guess. So what we can do is we can just at this point when we have if we have chosen j, then we can do a binary search of some sort, and we can remove all the element jobs that are on the right of like the value where uh, the jobs which are overlapping this starts,
Mm-hmm.
right? And then the values which are at the left of these will be the jobs that are not overlapping. So we can do something like j minus the index difference or something like that to return the answer till those jobs.
Yeah. Yeah. So, um, although the way you are fine, you are not clear about, and I think you need to work it out that how to find the set of remaining set of compatible jobs. That what you are trying to say. You are trying to say that here it will be the set of compatible jobs, right?
Yes, kind of.
In 1 to j minus 1. So you are left with, you have chosen j, now you are 1 to j minus 1 jobs. In that you find the set of compatible jobs, and the answer for that will be here instead of j minus 1. That. Now we can now, so I hope this is clear. Then how can we write the answer for, now we will discuss this, that how do we compute this set of compatible jobs that you were suggesting something, sort them and do binary search. So we'll discuss that. And now let us for now assume that we know what is the set of compatible jobs that after we choose j. Now what will be the relation, final relation of answer of j? How will we write that? So what will be answer of j?
That would be the max of these, I guess.
Yeah. Is it clear? So here we are saying that we will perform both of these actions. We will once pick j and compute the answer, other time we will not pick j and compute the answer, and whichever is the best answer we are going to take that. That is why we are going to use here max. So we are saying that answer of j is equal to max of answer of j minus 1 vj plus answer, let's call this cj, jobs which are compatible with j. That's Now what will be the mm what will be the base case here?
If we are on the first job, that would be the base case, I guess. Or maybe if we don't have any jobs left.
Yeah. Yeah, if we don't have any jobs,
Then we'll return zero in the business, I guess, because if we don't have any job, we can't make any profit.
right, right. So this is our final recur- recursive relation. Base case is j equal to 0. When we have no job left, then our answer is 0. And otherwise, we are going to take the maximum of when we pick the job j and when we do not pick the job j, and return that. Now if we write a recursive solution for this, that is going to have an exponential time complexity, right?
Yes.
Yeah, because the recurrence
2 raised to n.
relation here the recurrence relation, you can think in terms of Fibonacci series recurrence relation, like t of n is equal to t of n minus 1 plus t of n minus 2. Here we are not clear what this Cj is, but Cj can be maximum j minus 1 and something j minus 2, j minus 3, or anything like that. So in that case, the recursive solution is still an exponential algorithm, but there is a lot of there are many redundant subproblems in this. If we will try to solve this, then we will find that there will be a lot. I mean, we will form a recursive tree for this. We will find that there are a lot of redundant subproblems, and that is what we are going to use to reduce the time complexity. So then we can first let us discuss that how we are going to get this Cj, jobs which are compatible with J. So how will we find this?
As I was discussing a few minutes ago, I think the way we can find Cj is, first of all, we can sort this array on the basis of their finish time.
Hmm.
So we can kind of have them in like groups. So the first group of compatible jobs will be kind of in the most left region. Then comes the job which are next compatible, like in the
So
other.
why finish time and not start time?
Yes. So like for the problem that we have discussed earlier
Yeah.
about finding the maximum number of jobs that are not overlapping. When we sort these in an order of their finish time, then we can see that it became two groups, like Nildhara ma'am told us by those lines example. Like we have marked those intervals in lines, and as we can see, those were kind of like uh, they became into some kind of groups, we can say. So the jobs which were finishing first all came into one group, then the next, right?
Yeah.
We,
Okay.
we had into three groups. So then we can binary search, and only the groups that are having like some time that is overlapping, that would be discarded, and the remaining will be taken for the next function call.
What will binary search give you? So binary search, with binary search you are going to try to find out the job.
Yeah,
Uh,
the like the point where it separates the uh, acceptable and unacceptable jobs,
yeah.
something like that. However, with binary search, it might be a little bit complicated to do. We can still sort and do a linear search and do it, maybe.
Yeah, linear is also fine because anyway, sorting will take n log n.
Yeah.
No, I think linear is not fine.
But the thing is, we
No,
have to do
linear is
sorting
not fine.
in only one time, and
Yeah,
we can use the language specific sorting function to do it even faster in the first place. And then login operation, login length operations would be very faster for each recursive call.
yeah, yeah. So no, you don't need to do it each time. So we can pre-compute all of this information, right? We have n intervals or n jobs which are
Uh,
fixed given to us. So for
yes.
jth job, you can find cj.
Yeah, we can do that as well.
So it is like, let's take an example. If we have 1, 2, 3, 4. Now let us try to find C of 4. So here what is C of 4? I think I have, I'll just redraw it. I've just made it a bit not very clear. So C of 4 we are trying to find here.
CO4 is 1.
Yeah, C of 4 here is 1 because 2 and 3 are overlapping with it and 1 is not overlapping. So now we can sort. So how will we find? If we sort the intervals by their finish time, then we need to find the last interval before j whose finish time is less than equal to its start time. Right?
Yes. And as we have finished times in order,
Yeah.
therefore we can just run a binary search on the basis of the start time.
Yeah. Yeah, exactly. So that will take log n time, and we need to do this for all the n intervals. So n log n, and we have already sorted, that also took n log n. So overall time to pre-compute this. And in cj what will you store? You will store the this index of this last interval which was compatible, because all of the intervals before that they were sorted. You are working with the sorted intervals now. So in your algorithm above, which we discussed, this recursive solution here, you will be working with the sorted set of intervals now, sorted according to their finish time. And now you can pre-compute this value cj for every job, and that will be the index of the last job which is compatible with it, and all the remaining jobs which are coming before this will definitely be compatible with j, because they have their finish time smaller than the start time, smaller than the finish time of this one.
Okay, one more thing. One thing I noticed here is that if we are doing this on zero-based arrays, like arrays based on zero-based indexing,
Yeah.
then if we get the first item as our remaining set of jobs, like we have only one job, and that is at index zero, won't it overlap the base case in some sort?
Yeah, so then we can actually start our jobs from 1 and not keep anything for 0.
Yeah, and if we are accessing them, maybe do a -1 at the all time, right? Something similar.
Access in XX, sorry.
Uh, I mean to say that, if you're accessing the value that is the jobs, let's say we got the value of CJ as zero,
Yeah.
uh, then we will have to return, add the value of this and have to return at instant moment, because at the least, like if we are at the index 1 in the one based indexing system only, so if we are at index 1, that should also have some value of it, and that would be kind of 0 or something. I'm confused about here. Like there will be some kind of an overlap. I'm trying to think that.
Uh, Overlap with, I complete.
Overlap with the base case, I think.
Okay, let me think about it. So j equal to 0, we are saying. So j equal to 0 means here 0 jobs, 0th job. So there is no job. If there were one job, say j equal to 1 means first job. So if there were one job only, that would have been compatible with itself. There is no other job. We would have returned that one, like vj itself plus answer of j minus 1 would have returned 0, and answer of cj, so cj means the compatible for that should have been also 0. So so if there is no job compatible with it, or if it's the only job, that means no other job is previous to it, then cj should be 0, and that will handle it.
Yeah, I got it. Got it.
Okay. Okay.
I have a simple question.
Yes.
Somehow this seems to be unnatural. Does the dynamic programming, the spirit of dynamic programming, call for sorting the data?
The spirit of the dynamic programming.
Does it call for sorting your data and then proceeding for solution? Because I haven't ever come across any dynamic programming solution demanding for some kind of preparatory work being done and then proceeding for tabular solution. Am I clear?
Yeah. Yeah, here we are sorting only.
Because across the broad spectrum of dynamic programming problems which I have come across, I don't say that I have seen all the problems, but at least what I understood from the spirit of dynamic programming is it never calls for some kind of preparatory kind of work before it proceeds for a tabular solution, maybe a one-dimensional or a two-dimensional tabular solution. It
Right.
naturally takes the input data and then somehow devises a solution.
Yeah.
This problem seems to be a misfit for dynamic programming, from what I understood.
So uh, if we do not sort, I mean sorting. So sorting is necessary to find the CJ. That is okay. But
No, I don't deny that.
yeah,
I'm not denying that.
yeah. I
My
understood. I'm also like I'm just trying to think, if we do not sort and just work with the original set of the intervals, then will
because
it
that's how most of the dynamic programming problems are solved. So it seems to be slightly misfit here. That's the reason why I'm asking this question. I'm not debating that CJ demands for sorting or not sorting, or maybe I'm not getting into that.
Yes.
I'm getting into the whole idea of applying dynamic programming and the philosophy of dynamic programming and application of dynamic programming to this problem.
Yeah.
So am I missing something?
Hmm. I am not sure. Here, what I understand is that it won't work if we do not consider them.
I don't deny that for sure.
Yeah.
Because otherwise you cannot compute CJ.
Yeah.
Is there any other formulation that does not call for sorting? Because most of the dynamic programming formulations seem to be very natural with the given data. So that's only my anxiety to know that.
Can I add something?
Yeah.
I think that we can do it with the like raw data as well, but for that we'll have to compute every job. Let's say we'll have to compute the list of jobs that are compatible with it, and we'll have to search for only from them. So it's like if we are starting with a job, then we discard all the remaining jobs, and I mean all the jobs that are overlapping, and we'll have to do it multiple times. Like here we are sorting and grouping all of them that have to be discarded, but there we'll have to handpick all of those jobs that are not compatible. I think that would work, but that would require a different way of storing the information, as well as it would be much longer to compute as well.
Yeah. Problem solved. So if we don't sort it, then how will we find those set of compatible ones?
We'll Okay, we'll have to either we can pre-compute it as well, but we can calculate it during the run as well. I think so. Like the similar way, we are pre-computing all of this so as to make it efficient, right? If we do all this computation work inside the function itself, then it would be a solution to the raw problem. I mean the raw data, and but it would be a kind of lengthy for it to work and time consuming. Like the computation that we're doing just once will have to be computed all the way in every function call.
Hmm. So if we do not sort and we just take one interval and then discard the rest, sorry, take j minus 1, find the compatible ones. Yeah, we can do, but it's still not convinced. So here also I think it is necessary to sort and work with that, because we, similar to the um, because if we do not do that, then which is the jth job, and all of these, if we do it in order of finishing like time, in increasing order of finish time, then we know that all the jobs which are coming before j minus j have their finish times less than j. Otherwise we don't know that, and the formulation may not work, that formulation that we have here. And I'm not sure about any other formulation right now.
The way I understand it is that
Yeah.
let's say for each job, uh, in the lines that we have 1, 2, 3, 4 under. So let's say for each of these jobs, we'll have something like for like n squared pairs of a job and a job before it, right? So if there is one and we have nothing before it, let's say zero we have before it
Hmm.
in this pair, then it would be kind of saying that we are calculating for if only one like the job one is required for us, and like if we have a array of solution in order like we are doing in the RA example, like the solution that we're discussing. So that would also kind of create an order, right? When we search CJ, and then for that CJ element, we'll compute another CJ. We'll kind of get an order, let's say 0, 1, 4
Hmm.
for this example. If these have the higher values, right, in some sort. So then we are kind of calculating C1 0, and then for second we are calculating C4 1. Uh, that those are the pairs that we are calling, and in the end we'll have to compute only n squared pairs. So that would be done with dynamic programming, I think. Can I use whiteboard in some way?
Yeah. This one, I can share the
I,
Jamboard.
I think, yeah, there is a Jamboard here. Yeah.
Mm, no, it's not real. Okay, I'm unable to access it actually. Hmm. Maybe you need to
Maybe
change the settings if you.
maybe I can create another one and share my screen.
Sure.
Is my screen visible?
Yeah, it is coming up. It's visible now.
Just a second. Okay, so here what I was trying to explain. Okay, so let's say we have jobs one, two, three, and four in our sorted order, right? We have these jobs in our sorted order.
Yeah.
So when we are doing it with our approach that we have discussed right now, and let's say we have zero jobs as well. So when we are calculating it with our solution, then we are first at 4, then we'll compute Cj, which appears to be 1.
Yeah.
Then the Cj of this appears to be 0, right?
Yeah.
So we have kind of a sequence from 0 to 1, uh, 1 to 4, right? We have this sequence in our answer,
Hmm.
an invisible sequence that comes up in the stack calls. Or not the calls, but apparently the answer which we are taking, right?
But we don't know if this is the answer.
Yeah, we don't know it's the answer. Okay, but what I'm saying is that let's say for 4 we have, like for these we can compute like all the pairs of one job to a set of a previous job that we are trying to check, right?
Yeah.
Yeah. So now what we can do is, first of all, what I'm trying to show by this is that if we have pairs, then we'll have a total of n squared uh, pairs to calculate, right? There will be a total of n squared pairs.
What do you mean by pair?
Pairs means the current job, like this is the current
Yeah,
job.
4 is
Then
current
we
job.
have, yeah, then we'll have maybe one as the current previous job, or three as the previous job, or two as the previous job. Like anyone can be the previous job in our answer, but we'll have one, right?
Yeah.
Yes.
1 because it is compatible with 4, you're saying.
No, I mean to say that we'll have any one, at least one of the jobs that is compatible to it, right?
Yeah,
If
yeah,
no
yeah.
one is, then zero will be.
Right.
We have something that is compatible, right? So we'll have a current job, a previous job, and at max we have to calculate n squared set of pairs like these.
N square.
Okay, okay. I'll get back to this n squared later. I am like getting where we are getting confused. Okay. So what we can do is, what I am proposing is that for every job,
Hmm.
we check all the jobs which are like for 4 we'll check with every job, but we are getting the answer if we are like storing the time of 8, and for every other job we'll check like if it is not overlapping with 4.
Yeah.
I'm getting kind of confused to explain this. Maybe we can discuss this in the Discord server later. This will be a kind of hectic work to do right now.
Are you trying to say that for like once you're going to consider four as the last job, then three, then two, then one, so on. That's why n options are there for four for last job.
Yes, something like that. For 4, we are actually checking for every job, every of the remaining job, like what we can have for the max for every some job as its previous. Like for 4, we can check for if 3 is its previous job, then of the remaining jobs, what we can have the maximum, something like that.
But we are trying to answer when we don't have any ordering, right?
Uh, yes, we don't have any ordering sorted right, but we have the ordering that was given to us in the initial
Which
stage.
was random. There was no
Okay,
ordering.
it was random. So yes,
I mean, they have no ordering as such.
just kind of getting confused there. Okay, I have to think a bit for it.
Yeah, uh, I will also, I also need to think about this completely. Although I think that we consider the ordering because then we only need then the number of sub problems becomes small that we have to consider. Otherwise, if the jobs aren't ordered, then we'll probably have what I think is that we'll have exponential number of sub problems to consider.
Yeah, might be the case. That what I was trying to reduce. Like if if we are trying checking for all subsets, then the computation will be same as n square 2 raised to n,
Yeah.
and that won't be of any benefit. So what I was trying to do with this paired system is like kind of reduce it to n squared in some way using calculated values for random data. That was what confusing me.
Yeah, we can, yeah, try to think about that. I did not understand the n square approach.
I am also kind of like cloudy about it, so I have to think as well.
Yeah, sure, no, yeah. Thanks for trying. Okay. Yeah, so next time we are going to discuss the knapsack of all subsets problem that we had discussed. I mean, I wanted to discuss that problem also, but now we don't have time to discuss that. But I have already shared that problem with you in GitHub. So please do take a look at that, and we'll discuss that in the next week.
Sure.
Okay. Yeah. Okay. Thank you everyone for joining. I'm here if you have any doubts. Otherwise, we can end the meeting.
Are you on the Discord channel?
Yes, sir.
I have posted a couple of questions. I did not get answers related to week 10 quiz
So
regarding.
quiz. Okay, sir. Actually, so we have 3 TAs for this course. So quiz actually they have
Yeah.
designed the quiz questions.
Yeah. That's the reason I have asked you. Are you related to that? I understood. You are related to basically problem solving sessions.
Right.
So maybe can you prompt the other people to look at the Discord and then maybe if it is possible.
Yes, sir. Yeah, that is possible. I will tell the other TAs to look at week 10. You're saying, right?
Yeah. There is slightly ambiguity in a couple of questions. So I just posted the ambiguity also. Maybe somebody can clarify it.
Sure, sir. I will take a look and I'll ask them to take a look as well.
Okay.
Yeah.
Thank you, ma'am.
Thank you so much for joining. Thanks.
Thank you.
Thank you.